All right, this is Mr. Holsey with H Squared, Sufficiently Understood Science, and today we're going to be talking about chemical and physical changes. So matter is always changing form, size, shape, color, etc. And this is a fundamental thing in the universe. The universe is always changing. Matter is always changing. And there are two types of changes that matter undergoes, either physical or chemical. So let's take a look at physical changes first. So a physical change is a change of matter without changing the identity of the substance. That's important. We're not changing the identity of the substance. So in other words, we are going to change in state. Now, state means, from a solid, liquid, gas, or even plasma. And so a change in state is where we move from one of these or another. This can also apply to a change in size, shape, or mass. But the main point is it does not change. It does not change the chemical makeup of the matter. You have what you started with, just in a different form. So for example, if I were to get mad at Mr. Hansen and decide to throw him in a wood chipper. Now, at the end of the wood chipper, there would be little tiny pieces of flesh and bone and blood and all that kind of stuff and guts, but would it still be Mr. Hansen? Why, yes, it would still be Mr. Hansen. I haven't changed them chemically. Those are still the components of Mr. Hansen, but I have not chemically changed him. So some verbs used to describe physical changes include grinding, dissolving, eroding, which is what we talked about with weathering, eroding, deposition, ripping, tearing, breaking, or a phase change. So some other examples of physical changes is if I were to take a piece of paper and tear it into pieces. Now, while I have broken that piece of paper, it is still a piece of paper. I haven't chemically changed it. Dissolving sugar into tea. If I were to boil away the liquid, the tea, the sugar will remain. Salt dissolved into water, same thing. So this is whenever we remove salt from water, the boiling away water and leaving the salt behind, that's called desalinization. And cutting your nails or hair is also an example of physical change. So we're going to talk about 6 types of physical changes. We have melting, freezing, evaporation, condensation, sublimation, and deposition. Now, I want to make an important note right here for deposition. This is not what's happening with rocks. This is not what is happening with rocks. This is a different kind of deposition. So all phase changes are caused by adding or taking away energy. And energy occurs in lots of different forms, and the type of energy we're going to talk about today with this is thermal energy. In other words, heat. And so as we go through these, we're going to talk about how they are changing. And so what we'll have is talking about phase changes. So we have a solid, a liquid, and a gas. So as we are moving from a solid to a gas, heat or energy is absorbed. And as we move from a gas to a solid, energy is released. And so this is what causes these phase changes. And so they all are caused by adding or taking away energy. And the reason this works is because as you add energy to the atoms that make up these molecules, they begin to move faster and faster and faster. They can move past one another. So as solid, the energy is not enough for those atoms to move very quickly. That's why they are kind of stuck there. That's why it's solid. There's not a lot of energy. But as we go up, a liquid has more energy, so the atoms are able to move more freely. And finally, in a gas, they're able to move most free of all because they're now very far apart. So another thing to add into this is as energy is absorbed, density is going to decrease. And as energy is released, density will increase. So phase changes occur when matter changes from one state to another. In our cases, we're talking about heat. So as heat is added, we go from a solid to a liquid to a gas. And as heat is taken away, we go from a gas to a liquid to a solid. Now, as these phase changes are occurring, so if we're going from a solid to a liquid, there's going to be a point where the energy kind of evens out. And this is because there's still solid aspects to it. And so it's going to remain at that melting point until all the solid is melted. And the same thing goes for liquid. As it's moving towards the evaporation or boiling point, it's going to even out right there until all the liquid has boiled. So different phase changes, we have melting, where matter changes from a solid to a liquid. So here we are adding energy. So thermal energy. When more heat is added to matter, the particles move faster till the bonds between them break, and they're able to move more freely. And so density, like I said, is going to decrease because those atoms, the bonds are broken, and those are going to be moving apart. Matter is able to move apart, so it's less rigid. Evaporation is where we go from a liquid to a gas, but more importantly, where it's occurring at the surface. That's going to be very important in a second when we talk about boiling. So energy is only added to the surface of a liquid. This is why we don't see like bubbles and boiling like what we would see for evaporation when it comes to boiling in like a puddle. We don't see that because it's only affecting the surface of the water. It's only affecting the surface of the water. So if I have a little water right here, that thermal energy is only directly hitting the top of the water. So that top part of the water is going to warm up faster. And so below it, you have cooler water, which is not going to be at an evaporation point. And below that, even cooler water. And so only the top layer of the water will be evaporated away. Now, this is really a good thing for us because if it were to warm up the entirety of the water, then our oceans would cease to exist. They would boil away. Speaking of boiling, matter changing once again from a liquid to a gas. It's from a liquid to a gas. But this time, all throughout the liquid. Okay? So energy is going to be added to all of the liquid, and the particles are going to move very, very fast through the entirety. So it's not going to, it's like when you put a pot on water. So the reason why we see the bubbles pop up is because some particles are moving fast enough inside of that liquid to go ahead and change to a gas while they're in the middle of the liquid. And so it's going to bubble up. Now, that's not like air or anything like that. It's water vapor when we're boiling water. So it's bubbling up. So this is why it's not a chemical change, but it's a physical change because we're not changing what it is. That's water vapor being released. It's water turning into a gas. So density will, again, decrease, and water will boil at about 100 degrees Celsius. Now, sublimation is where matter changes straight from a solid to a gas. So heat's added very rapidly, so much so that instead of going solid to liquid to gas, we completely skip that liquid stage. So this occurs often with materials that have an extremely low boiling point. This is going to decrease rapidly as it heats rapidly. One of the best examples is going to be dry ice. Now, this is carbon dioxide. It's actually carbon dioxide. And so carbon dioxide at room temperature is a gas. And so this frozen carbon dioxide, this dry ice, when it's set out on room temperature, it immediately goes to a gaseous state. It immediately vaporizes. So vaporization is a general word for any substance changing to a gas. Boiling, evaporation, sublimation are all examples of vaporization. Now, we've been talking about adding energy. So now we're going to switch roles here and we're going to start taking away energy. So condensation is matter changing from a gas to a liquid. The energy is being removed here. We're going from a gas to a liquid and we're removing energy. You've probably experienced this in your life if you've ever gotten a glass of ice water or gone to McDonald's or something like that, where the outside of your cup becomes covered in water. Now that liquid is not seeping through the cup, but instead the warmer air that's surrounding the cup is interacting with the cold cup itself. And that warmer air is being rapidly cooled down to where the moisture in it is now collecting on that colder cup. So the attraction between the particles begin to pull the particles closer together and decreases that density, or increases that density, and so they're closer up to one another. And the matter goes from gas to liquid. Freezing is changing from a liquid to a solid when we're moving a lot of energy. So those particles move even slower than in liquid, almost not at all. They're still moving, but very, very, very slowly. And so it is a solid. We're increasing that density. As we remove energy, we increase density. And finally, deposition. Now, this is not what we do with rocks. When matter changes from a gas directly to a solid, it's like the opposite of sublimation. Heat is going to be taken away rapidly. This is how snowflakes are formed. Okay, you would imagine that it's the rain and stuff in the clouds being pulled up and cooling, but actually it's water vapor being pulled up rapidly and forming ice crystals immediately. Whenever it's liquid that is pulled up, it's going to turn into hail, ice storms. But snow is different. It's an example of deposition, where heat's taken away rapidly, so fast. That's why snow is very fluffy as opposed to ice. So the term solidification is a general word for any substance changing to a solid. So there's your key hint right there, solid. It's in the name. So why doesn't a change of state mean a chemical change? Well, it doesn't change the chemical makeup of the matter. You have what you started with, just in a different form. When we go from ice to water, from water to water vapor, we still have H2O in each one of those. There's still H2O. And so here's a quick diagram for the changes of state. And so I love this diagram. It's one of the best diagrams I've ever seen. So to review, as we go from a solid to a liquid, it's melting. As we go from a liquid to a gas, it's evaporation. As we go from a gas straight to a solid, that's deposition. As we go from a gas to a liquid, that's condensation. As we go from a liquid to a solid, that's solidification. And as we go from a solid straight to a gas, that's sublimation. So let's talk about chemical changes. Now, with chemical reactions, you're going to end up with usually two outcomes, because these are going to require energy. So you have two different types of reactions. You have endothermic and exothermic. Now, endothermic is where energy transfers inward. Okay? So if we have, let's say we have a solid right here. All right? What's happening is it's taking heat energy and pulling it in to the solid. Kind of like those instant ice packs you get at the store. It's actually stealing heat. That's why it feels cold, because it is taking heat away. So endothermic will be cold. Exothermic is going to be a little bit different. So this is where energy transmits outward. So the same solid here is now sending energy outward. Okay? And so it's radiating energy outward, basically vomiting heat on you. And so that's why endothermic feels hot, like it's warming up. Now, the biggest difference between a physical and chemical reaction is in physical reactions, a lot of times you can change it back. You're not changing anything. But in a chemical reaction, you're taking two or more substances, combining them into an entirely new substance with all new properties. And you cannot change it back easily. Yeah, there are processes where you can change it back, but it takes a lot of energy, a lot of effort. So you cannot change a chemical reaction or a chemical change back easily. So when identifying a chemical change, you're going to look for some telltale signs. First of all, fizzles or bubbles, some kind of color change, heat given off, light given off, some odor, might smell different. And most of these are going to have some heat energy required for the reaction to occur. And sometimes we're going to see a new substance formed. Sometimes in the case, it will be a precipitate, which is a solid. Sometimes you'll see pour two liquids together, and all of a sudden you see solids forming inside of it, like little crystals or gas bubbles. And so these are the telltale signs of a chemical change. Now, not all of these are going to occur at the same time. You may get bubbles, you may get a color change, you might get both, you might get heat, you might get, and so not all of these are going to occur at the same time. So, for example, I'm going to show you this little video here. So they poured these two substances together, and we've gone from a liquid to a solid. Here it's a similar process. We have two substances that are going to be poured together, and it's going to go from a liquid and powder here. The two are going to react into a solid. So some examples: baking bread. You no longer have flour, you no longer have eggs and milk and yeast. I can't take a piece of bread and remove the flour. It's chemically changed or chemically bonded. Alka-Seltzers or effervescent tablets, they may be breaking down the tablet, but if you look, what is it releasing? It's releasing gas. You can't get that gas back in that tablet. Baking soda and vinegar, rust, whenever objects rust or tarnish, such as right here. And another example is burning wood. Okay, the heat's added and it's changing it into ash. And so right here we have an example of a time lapse where something is rusting. You can see it kind of falling away. So that's it for this tutorial. Remember to like, share, and subscribe. Hit the bell icon so you know whenever we post a new tutorial. And this was Mr. Holsey for H Squared, Sufficiently Understood Science. See you next time.